Welcome to another fun-packed edition of Starry Skies, our monthly magazine here on Forest FM, where we tell you all about what's to see in the night sky this month. I'm Mark Hardaker.
And I'm Steve Tonkin.
And we've got a fun-packed edition for you this month, talking about the stars and the planets.
Haven't we just? Because there's a lot of planets available if you care to go out and look.
Absolutely. It's a great... And also our skies, better say it. I need a new set of teeth here, Steve.
Yeah.
The skies are getting darker as we get towards the equinox at the end of September.
Yes, and getting darker earlier, and that's the important thing, because it means you don't have to stay up really late in order to do anything.
Okay, so how was your month of August? Did you actually get any astronomy done?
Very, very little. I was lucky. I was actually on holiday in Cornwall, and it cleared up on the 11th, so could actually saw a few Perseid meteors on the 11th, but that's really it.
Yeah, and I was away on the continent of Europe, and we had rain and cloud the whole time, so I didn't see, unfortunately, one Perseid. So we're going to have to wait till next year again, aren't we?
Yep.
Anyway, so let's have a look at the solar system and the moon and planets for September. Starting with the moon. How about the moon this month? We've got on the 29th, isn't it? I think we have a full moon.
A full moon, that's one they call a supermoon.
Oh, what?
A supermoon.
What's a supermoon, Steve?
Well, I reckon that to be classified as a supermoon, it has to be sporting a red cape. It has to wear its underpants also red outside its trousers, and then it's a supermoon. But it's otherwise no. What it really is the moon's orbit round the Earth isn't a circle. It's a bit of a squash circle, an ellipse, and it is sometimes closer to the Earth than at other times. And if you get a full moon when it's closer to the Earth, it looks a few percent bigger. And of course, when it's on the horizon, it looks bigger anyway due to something called the moon illusion. And it's great because it gets people out there, and they can, and people can actually see this, and it's just a fun thing to do, but it doesn't really have any scientific validity.
And it doesn't. Can you really tell the difference? We're both amateur astronomers. Can you really tell the difference when you see a full moon that's super?
No,
and neither can I. So it's media hype, but we like it because at least it puts astronomy in front of people and encourages more people to get outside and look at the moon and stars and planets. That's great. So what else do we have then? The full moon, that late September full moon is called the harvest moon because in the past, of course, it used to help our ancestors as they were gathering in the harvest. Kept daylight or moonlight available for a few more hours. On the 4th of September, we have the moon near Jupiter. So if you go and have a look out on the 4th, in the early morning, so after midnight, I would say, you will see the moon rising. It will be just about a half moon rising in the east, and it'll be very close to Jupiter.
Well, if you've got binoculars, you can look at Jupiter and you will see what Galileo saw.
Indeed you will. So let's talk about the planets, shall we?
Indeed.
And let's talk first about the inferior planets. What are they?
Oh, they're ones that you just brush aside because inferior planet. It's old terminology.
Right.
And what it means is that they are between the Earth and the Sun. They orbit between the Earth and the Sun, whereas the superior planets, they don't go around with their noses in the air. They orbit further away from the Sun than the Earth is.
That's right. So the inferior planets are Mercury and Venus. Then we've got the Earth, and then we've got Mars, Jupiter, Saturn, and so forth. They're the superior. So how about the planets this month? Well, you're really going to be lucky this month and going to see the innermost planet, Mercury. It will be a lovely object in the morning sky if you have a clear view to the east. It will be best seen on the 22nd and 23rd of September. Clear and bright, shining low in the east in the constellation of Leo. Yep. Now, you're going to have to get up a little early, around 5:30 in the morning to see it because, as we just said, Mercury is very close to the Sun, so it only appears in the sky very soon before sunrise, or if it's in the evening, after sunset, because it's so close to the Sun. But on the 23rd and 24th of September, 22nd, 23rd of September, you should be able to see it. Have a look in the east, and you should see it low down. Sometimes it's pinky. I think it's sometimes a little pinky.
I think
Funny.
that's because of its light coming
illusion.
through Earth's atmosphere, yes.
But
Yeah, but about, if you get up about 6 o'clock, well, if you're looking out there about 6 o'clock, you should see it. It's
yeah.
quite good.
And again, those that are commuting to work, early commute across the A31 in our region towards London direction, so eastwards, you should see it nicely as you get to the top of the A31 in the forest there. However, the next planet out, Venus, you cannot miss Venus. Absolutely cannot. So it's spent weeks and weeks in the spring. Remember when it was so bright in the spring?
Yeah.
It was like a searchlight in the spring and early summer, but it got closer and closer to the sun and then shot quickly between us and the sun last month, and it's now emerged into the morning sky, where it's unmistakable in the east in the constellation of Cancer for the whole month.
So why is it unmistakable, Mark? What about it is unmistakable?
Because it's the third brightest object in the sky. The sun and the moon you can't miss, but other than that, brilliant white, bluey white Venus can't be missed. It's so bright in the sky. Early in the morning again, at the beginning of the month, it will be a thin 11% crescent if you use your small telescope. But it's so close to us that Venus will be shining down. You will not be able to miss it. It will peep above the horizon about 3 a.m. in the morning, mid-month, but you can see it all the way through to sunrise.
And if you're somewhere dark, you can see Venus can actually cast a shadow. It is that bright.
Yeah. And certainly this month of September, when Jupiter is still so close to us and sufficiently brilliantly or brightly illuminated, it will be an excellent test to see whether it will actually cast a shadow. So now, the superior planets. So now we're looking from the Earth outwards and away from the Sun. So how about Mars?
No, not visible this month.
So why not?
Because it's the other side of the sun from us.
Right.
So it's lost in the sun's glare.
And it'll be gone for several months, I think, because it's moving away from us and it's behind the sun. It'll take quite a few weeks and months to reappear.
Yeah.
So forget Mars until probably Christmas, is it?
Well, probably November, I think.
Yeah.
We'll just begin to see it again. Yeah, and the reason that is because we're both moving around the sun in the same direction, of course.
Yeah.
So we're sort of catching up on it, but not yet.
But if we were to look south during the month of September, in the constellation of Aquarius, there you will find halfway up the sky, if you're looking south, the most beautiful planet in the solar system, which is Saturn.
Isn't it lovely?
It's just lovely. It was at opposition to us in August. That means
Well, that means you've got the sun, then the Earth, and then Saturn in almost a straight line. Not quite a straight line, but they are. And what that means is that Saturn's light is reflected back at us slightly more strongly than at any other time, so it and its rings shine a little bit brighter.
That's right. So when a planet is at opposition, it's the best time to see it. It rises as the sun sets, it sets as the sun rises, and at midnight the planet is due south of us and as high in the sky as it can get. As I said, it's not particularly bright this year, is it?
No.
Not overly bright.
Well, part of the reason is that it's like Earth's spin axis is tilted to its rotational to its orbit. So is Saturn's, and so its rings, depending on where it is in relationship to us, can either look edge on, or they can look as though they're really open, they're really full on. So when we're looking at them sort of slightly from above or slightly from below, if you think of it like that, and we're getting closer and closer to edge on, so they reflect less light in this way.
So Saturn is at its brightest then when the rings are fully open, is that right?
When the rings are fully open, which will be about another 9 years, I think, now,
right.
and when it's at opposition.
So it cycles then between edge on and full on every 9 years or so.
Well, it's 29 years for a complete cycle.
Right.
So they're not fully closed yet, so we've got another year or so until they're closed, and then After that, they'll start opening up again.
But you can still see them. So
Oh, yeah.
if you do have a telescope, set it up in your garden in a dark backyard if you can, looking south, and you'll see Saturn. It's in a pretty dismal part of the sky, really.
Yeah.
Isn't it? The constellation of Aquarius is not one of our constellations of the month because it's a bit dim.
Most certainly not, but what that means is that Saturn stands out.
Yeah. So you should be able to see it. How about halfway up the sky? A bit lower than that maybe, but as a yellowy star. Train your telescope on it with some magnification, maybe 60 to 100 magnification. Point it at the planet, and you will get what we call a wow moment.
Oh, yes.
A wow moment. And you'd be surprised. There are so many astronomers like Steve and I and many others in our Fordingbridge Astronomers and Wessex Astronomical Society who saw those rings when they were children. In my case, I was 10 when I first saw that wow moment of the rings of Saturn, and it's extremely impressive. Show your kids. Get your kids out. Show your children the rings of Saturn. It might change their lives. It really might. So that's Saturn, which is due south during the whole month of September. You can't miss it. What about Jupiter?
Well, Jupiter is a bit further to the left. It's in the constellation of Aries. And as you said, it's near the moon on the 4th. And it's really worth looking at with binoculars. It mentioned you can see the moons that Galileo saw. But if you have a telescope, you could also see markings on it. And, of course, the most famous marking is the Great Red Spot, which is it's a storm that's been raging for hundreds of years. And it's actually shrinking, so it's I suppose the middling salmon pink spot now rather than great red.
It's certainly when I was much younger, say 20, 30 years ago, it was definitely a great red spot.
Yeah.
But it's faded away, got smaller, got pinkier rather than red, so it's not as prominent as it used to be.
No, but it's there. And
Still there.
If you could see that, just think at the moment. 2 Earths would fit into that spot side by side.
Yeah, it's
it used to be 3.
Yeah, yeah. So how to find Jupiter? Well, the easiest way is, let's suppose you're looking at Saturn now. So we're looking south, halfway up the sky, there's Saturn. You found that one. Then look 45 degrees to the left. So just turn to the left and low in the sky towards the east. Again, you will not be able to miss Jupiter. It's the 4th brightest object in the sky. Moon, Sun, Venus, and Jupiter. So it's a brilliant yellow object rising. It comes above the horizon about 9 p.m. in the middle of the month. But you won't miss. You can't miss it. It's so bright.
Great.
And as Steve says, with the binoculars, you can't miss the moons, the Galilean moons, as they orbit around the planet, and fantastic sight they are too.
There are 2 more planets out there, which are Uranus and Neptune, but we'll talk about those next month.
Yeah, we're gonna teach you. We're gonna try and get you to find them, and let us know if you can. Especially Uranus. Uranus was discovered, as many of us will remember, by William Herschel in Bath, in his house in 1781. So we'll teach you and try and get you to see Uranus during the month. Okay, so what are we going to do now? We're going to talk about constellation of the month, shall we?
Okie doke.
So what's the constellation of this month?
It's a square. Well, it's not actually quite square. It's a square. It's the 4 bright stars form a square, and it is called the Square of Pegasus. Although, as we'll discover, although it looks like it's one of the squares, it's actually one of them. The top left-hand one is actually in a different constellation.
Just to make it very complicated.
Yeah.
But it's Pegasus is actually a large constellation. So this square that we're referring to isn't a little tiny thing in the sky. It's quite large.
Yeah,
in
indeed.
fact, Pegasus is the 7th largest constellation in the sky, and it was one of the original 48, I believe.
It was, yeah.
Identified by Ptolemy in the 2nd century. It does look a bit like what it's meant to be, which is a flying horse. However, it's upside down.
Yep.
So its head is pointing down, its feet are pointing in the air, and it's rising in the east. And by mid-month, you should be able to see it east and south. Can't miss it, really. It's a very nice, an obvious square in the sky. We have a map of it on our Forest FM fan website. We also have the same map on our Fordingbridge Astronomers and our Wessex Astronomical Society website too. So have a look there and you'll see the shape of the constellation and also where some of the stars are that we're going to tell you about now.
Mm-hmm.
So, which star shall we start with? Why don't we talk about Enif?
Okay.
So if you imagine, again, your flying horse upside down with the muzzle pointing east-ish. Sorry, westish.
Westish, definitely.
I've got my directions. My compass is all wrong again this morning.
The way I find Enif is if you've got the square, you take the bottom two stars of the square, and you go pretty much the same distance again to the right.
Which is west.
Which is west. Which is west. The bright star near there is Enif, or Epsilon in astronomer speak.
Yeah. So this is a super giant star. It's orange, and if you take your binoculars or even with the naked eye, but certainly with binoculars, you can see it's quite obviously yellowy orange. It's about 690 light years away from us, and it also, which is common with many orange and red stars, it's slightly variable in brightness.
Yeah.
So it changes every few months, not by much, but it is a variable star.
Yeah. And what's a light year, Mark?
A light year is the distance that light travels in 1 year. So imagine light's doing 186,000 miles a second.
So that's 7.5 times round the Earth at the equator.
Per second.
Yep.
Right. So in 690 years, that's the time it takes for the light from this yellowy light from Enif to arrive here. 690 years. So we're seeing it back in the time of William Shakespeare. Yeah.
Yeah, when you compare that to the light from the moon, it takes not even 2 seconds to get here.
Yep.
And the light from the sun takes 8 minutes and 19 seconds.
Yep.
That's really...
So another star, when you have a look at the star chart we have on the website again, the star to the top right of the square is called Shiat. It's the second brightest star in Pegasus, though, of course, the Greeks called it then Alpha. Beta is the second letter, so this is Beta Pegasi. And that's a red giant, so it's not actually yellow, it's red. And again, with your binoculars, there is no mistaking it. It looks like a red, not a drop of blood, but in that direction.
So
it's orangey,
rusty red.
Rusty, that's a good description, Steve. This one is 196 light years away. So about a third of the distance or less of Enif. But it's really quite prominent. Those two stars, orange and red, are a good test for your eyesight. You should be able to see that they're coloured for certain. Pegasus also has a number of deep sky objects. Do you know what they are, Steve?
Deep sky objects are objects that are not part of or directly part of our solar system, so they're deeper into the galaxy than the solar system is. Hence deep sky. Some of them are very, very deeper and actually away from the galaxy, which we can come to in a bit.
Yeah. So the first one is what we call Messier 15, M15. It's a globular cluster of stars.
Which is?
A globular cluster of stars. Imagine that you have a snowball, right? So you get a handful of snow, you pick it up when it's crystalline. You know, when it's melting a little, it's crystalline. Each of those little crystals of ice is a star. So imagine that you've got a handful of stars. That is exactly what M15 looks like. Probably 100,000 stars, something like that. And these globular clusters orbit around our galaxy. So whereas the stars we've talked about are hundreds of light years away, M15 is 34,000 light years away.
Wow.
That's a long way, isn't it?
So light takes 34,000.
Yep.
Yeah, if you think what was going on Earth 34,000 years ago, well, we don't know, really.
We don't know, really, do we? No. But, so you can find M15. It's on our star chart. Again, look on the Forest FM website. It's just off the nose of the flying horse, so just a little bit extended from Enif.
Yep. A way to find it, just down to the left of Enif, there's a not quite so bright star. And if you take the distance between those, and then half of that, again, the other side of Enif, that's about where you'll find M15.
Yeah.
And it's, in binoculars, it'll just look like an out-of-focus star, but if you've got a small telescope, it's just glorious.
Yes.
It breaks up into stars.
Absolutely. And it's marked on our star chart with a yellow circle with a cross in it, which is the standard icon for a globular cluster.
Yeah.
So that was discovered, would you believe, in 1746, because it's quite a bright globular. And then later catalogued by our friend Charles Messier, the French astronomer in Paris, as his 15th object to avoid that is not a comet. He was a comet seeker, and he was trying to find comets, and these things kept getting in his way. And this was the 15th object that got in his way, right?
Indeed.
So what else do we have? We've got other deep sky objects. We've talked about the stars being hundreds of light years away. We've talked about the globular cluster being 34,000 light years away. But how about the next object is NGC 7331. Have a look on the star chart again. NGC 7331. And this is a spiral galaxy. And it's 34 million light years away. A wow again.
So that's halfway back to when the dinosaurs were wiped out, approximately, that light left there?
Absolutely. So this is a separate... What's a galaxy? What's a spiral galaxy?
It's a group of stars, kind of hundreds of thousands of millions of stars, so we're talking huge numbers, astronomical numbers, shall we say? Excuse the pun. And they are gravitationally bound and orbiting a black hole in the middle. Now, a black hole is, someone once said it's where God divided by zero. It's a mass of stuff that is so massive that even light can't escape it. But because it's so massive, it can hold stars in orbit around it.
Right. And most galaxies, most spiral galaxies, have at their centre a black hole, as does our own Milky Way. So what you're looking at with NGC 7331 is a spiral galaxy, not unlike our Milky Way, actually, but 38 million light years away. It was discovered, again, by William Herschel. Did you know that? William Herschel discovered it in 1784, again from his house in Bath.
I did not know that.
And they didn't have any lights outside. They didn't have any street lights or neon to block the view. They must have had a clear, beautiful view of the night sky from Bath. So, and also this one was the first to be, or one of the first to be recognised as a spiral galaxy.
Yeah.
If you've got a decent telescope, it's not much to see in binoculars. In fact, you probably can't see it in binoculars, Steve.
Well, you can just you can make it out as an indistinct little fuzzy patch. You think, why did I bother with that?
But with a 6-inch or an 8-inch telescope, a bigger telescope, you can definitely see that this is a spiral galaxy. Lovely. So that's our constellation of the month. Again, do please have a look on the website and see what you think. So I think we're finished for the month.
We are.
So we shall look forward to seeing you in the next month for our October Starry Skies. But don't forget, you can come to visit us at Fordingbridge Astronomers, at Wessex Astronomical Society. We are a bunch of astronomers willing to help, especially newcomers come and join our hobby. Look on the websites, and we look forward to meeting you in person at our meetings.
Indeed.
So with that, from Mark Hardaker, all the best.
And from Steve Tonkin,
clear skies.
And keep looking up.